Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place, 15,000 square miles of them. There are tiny cold traps that are only 0.4 inches wide, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny. But still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says 15,500 square miles of the lunar surface could have the capacity to store water. But no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue. Highland regions are yellowish, with faint traces of pale and pink. Colors are not the same everywhere because of different amounts of various metals that are present on the moon, like titanium or iron in the surface minerals. Our eyes are not sensitive enough to pick out such differences from this distance, but the majority of the lunar surface consists of minerals that are naturally gray, and that's mostly the color we see from our planet. When you're in space, you can't walk on the ground. No gravity, so no need to wear shoes. That's why astronauts mostly wear socks, or eventually add another warmer pair if they're cold. But something strange might happen to your feet while you're up there. First, if you have calluses, they may fall off after some time. One astronaut described his experience and said the bottoms of his feet became very soft, while the skin on the top of his feet became very rough, like alligator skin. He engaged the top of his feet to get around when he was using foot rails on a space station where they stay. It's not easy up there. Astronauts on the International Space Station, ISS, have to use foot rails and loops to remain steady. When they have to do regular things, like just getting a haircut. When they want to do training, they can strap their feet into sneakers on the exercise equipment. It's essential for them to exercise way more than they'd have to on Earth, around 2 hours each day, because the human body isn't used to moving or performing any actions we normally do without gravity that kinda holds us together. Plus, if you stay in space for a longer time, you can lose much of your bone and muscle mass. For example, you can lose almost 20% of your muscle mass if you spend only 11 days in zero-gravity conditions. But if you were up there, there's no point in using weights, right? Zero gravity affects them too. Instead, astronauts mostly use a device outfitted with 2 small canisters that create a vacuum and allow them to pull against a long bar. On the ISS, you can also use a bike and a treadmill. Did you know that NASA spent millions of dollars developing a pen that you could write with in zero gravity? A pencil is not the best solution for space travel. They have a habit of breaking and shattering, which can leave graphite dust behind. Also, they're wooden, which brings a high risk of fire in the pressurized, oxygen-rich capsule. That's why even such an everyday thing as a pencil can be life-threatening in space. So, they had to develop the space pen. It writes crisp and clean, and can't rely on gravity to make the ink flow. Instead, it uses compressed nitrogen to force ink out of the nozzle. This way, you can write while you're floating upside down, or even submerged underwater. Even when they're up in space, astronauts still face everyday things, like that unpleasant itching sensation on their faces. They can't just satisfy it while in their spacesuit. They need to improvise, so sometimes they scratch the spot with a microphone attached inside of their helmet. Sometimes they attach patches of Velcro inside their helmet for such things. One of the most complicated issues with space trips is how to protect astronauts from space radiation. Our body has not evolved to handle proton storms and cosmic rays coming from the sun. Of course, spacesuits and the rest of the equipment are essential. Some research also showed an antioxidant-rich diet that usually includes a bunch of vegetables like spinach, tomatoes, and beetroot is promising when it comes to reducing the bad effects of radiation. Astronauts didn't always wear white spacesuits. During NASA's first manned spaceflight project called Project Mercury, they had silver suits. But none of the astronauts went out and explored the vacuum of space back then. Silver is not a good color for that, because spacesuits have to be highly reflective. White is the best for that. That color is the most effective for reflecting radiation while in outer space. We're on Earth, which means the atmosphere is like a shield that protects us from 77% of radiation coming from the sun. But astronauts don't have such protection up there, and this means they're very vulnerable to severe sunburn and extremely high temperatures. A white spacesuit helps, the same way as white paint on your walls helps you keep an entire room cooler. A lighter color will absorb 35% less heat. White is not the only color in their closet. When heading into space or coming to Earth, they sometimes wear a bright orange suit. It's a color that attracts attention, so if anything goes wrong during landing and astronauts have to quickly leave their ship, the rescue crew will spot them more easily. But times are changing, so today we have more sophisticated tools to locate astronauts that need help, such as GPS trackers and transponders, so suits don't have to be orange anymore. Floating through space. Everything's peaceful, and you're enjoying the magnificent view of the dark and quiet infinity filled with billions of stars, planets, comets, suns, moons, and so many other things we'll probably never even discover. 95% of our universe still remains a mystery to us. But at least the view is awesome. But it's only good if you're tethered. What if something goes wrong on your spacewalk and you detach? The whole scene goes from a beautiful dream to a nightmare in a second. But don't worry. NASA has designed a special jetpack called SAFER, Simplified Aid for EVA Rescue. It fires compressed nitrogen from 24 thrusters, which is how it can steer the astronaut back to safety. In theory, you could vent some gas from your suit too, or maybe throw a tool in the opposite direction, which is how you'll push yourself forward. But it's tricky because you'd need to throw it precisely in line with your center of mass. Otherwise, you'll just start uncontrollably spinning, and before you know it, you'll become so disoriented you'll have no idea where to go, even if you could. But SAFER will automatically detect rotation and use its jets to help you stay oriented towards the safe spot. It took scientists 10 days to teach a goldfish to drive a car. They taught it to move its own tank towards a certain target, and in return, the fish gets a treat. This research could help us navigate through space one day. There has to be some mapping happening in our minds. That's how we potentially link our body parts and movements to changes we go through when we're in space. That's how we'll know how far we can extend our arm to reach for a cup of coffee without going too far and knocking the coffee over. The movement control is not the same as under the force of gravity, and we need to be sure if such maps in our brain differ between sea and land, or if it's something universal. So when I say scientists taught a fish to drive, that basically means if the fish saw a target, it should touch the wall of the tank facing the desired direction. That way, scientists could guide the wheels and move them where the fish wanted to go.
Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the Moon. They named it Kamo'aliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light, similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger. But nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche Limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche Limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.